Okay, so this week, this lab, we're looking at building locations, building layout. Oh, what the hell, let's do it anyway. If you excel, we were talking about Microsoft earlier. If you excel, people spreadsheet about you. All right, thank you, good night. I can always edit that one out. Anyway, looking at building locations. So here's the plan for this lab. I want to go through this and I want to do some hand calculations. Is if you have coordinates of some points and then you have the plan, calculating all the angles and distances if you were laying this out kind of an old school conventional way. Then the plan is to go outside, put some information in the data collector, just being control points and line work, using the line work, just staking out the line work to create your own offsets. Kind of show you how you can do this a little quicker and easier. But I want to get the math into this, and I want to get everybody try to more practice with math. So what I have on the lab, which I still need to get on Brightspace, and I will add this lecture to later. I just have a list of general equipment, and then I have a list of coordinates. The 100 point numbers are traverse, and 500 and 501 are building corners. Now, this is kind of a smaller house. We'll see this when we get a little further along. If you were to go lay out this in the real world, this is why I want to try to make it more lab friendly when we go outside, is you'll have these coordinates already in your data collector, and like I said, the line work, and we can calculate our own offsets in the data collector very easily, which I'd like to show you later. So we have a list of those coordinates. I would like for you to calculate the bearing or azimuth, whatever you prefer, for each line listed below. So we're going to say we were occupying point 103 and backsighting 104. We have the coordinates. Calculate the bearing and distance of that line. The next two we have, we're saying we are occupying point 103. What is the bearing and distance from 103 to 500 and 103 to 501? Once we get those bearings and distances, we want to come down here and calculate the angle in between those bearings, or azimuths. So if you were occupying 103, backsighting 104, this first line here, we have you're setting our backsight, we're establishing our baseline. That would be our zero angle. If you're occupying 103, backsighting 104, turning to 105, what angle to the right are you going to actually turn in the instrument and the distance you're going to go? Same thing for point 501. So this is going to be the first steps of calculations that we're going to work through. Let's talk about the bearings and distances here. So what we have are control points 103, 104. What I would like for you to do is take the coordinates and calculate what is the bearing and the distance between those 2 points. I'm going to cheat this one right away in case anybody has not noticed. Down here at the bottom, I already got my distance. And if you notice, these coordinates are rather large. These are actual real state plane coordinates. I went out in the front of the yard of school, shot these traverse points in with some GPS. That's how these coordinates were derived, and I took the buildings and moved them accordingly. So that way I could put it on, put these points in CAD, bring in an aerial view, and make sure like I don't have any buildings sitting in the middle of trees or anything out in the front. So if I'm looking at coordinate 103, let's say I got a coordinate somewhere down, 103 is down here. It has a northing, has an easting. We'll look at the coordinate for 104, and it looks like my northing is bigger. So it's going to be up here a little bit. My easting is a little bit less. So let's just, for sake of a picture, we'll draw. Here's going to be 104. We know the northing, we know the easting. If I don't draw my line right, I'll just move my point over a little bit. I wasn't going to write out the northings and eastings. We have them on our sheet here. So what we want to do is kind of break this down into latitudes and departures. Latitudes would be your north-south line, your departures, your east-west line. So far, so good. I want to pick a coordinate, one or the other, and I'm going to subtract the northing from the northing and then the easting from the easting. So let's see, that would be a good way to write this down here. This would be the northing of 103 minus the northing of 104. That will be your latitude. Your departure would be the easting of 103 minus the easting of 104. Once we have that, the northing again is our north-south line. To calculate our bearing is going to be the angle from our north-south line, our meridian, to our line in question. We know our departure, we know our latitude. If we look at our SOHCAHTOA that I usually write down, opposite divided by adjacent will equal the tangent of that angle. We'll just write down the bearing is equal to the inverse tangent of opposite the departure divided by the latitude. And the distance is just going to be the latitude and departure right triangle Pythagorean theorem. So we'll say latitude squared plus departure squared. Take the square root of that. And that's how we will calculate our bearing and distance. Has anybody done this yet? Have any of these calculated? All right. What is the bearing between 103 and 104? 0 degrees. One more time.
20 minutes, 45 seconds.
Okay, so it's a bearing. Which quadrant are we in?
It would be northwest.
Anybody confirm, deny that? Okay, excellent. From 300 to 305, so we want to do the same thing. Let's get this out of the way here. We'll write this down here. North, 0 degrees. 20 minutes, 45 seconds west. Okay, let's look at 500. Our northing from 103 to 105, or sorry, 103 to 500. Our northing's a little bit bigger, our easting is a little bit bigger, so let's just say 500's over here. We'll go through the same thing. We have a coordinate, a northing and an easting for this point. So if we start back over here again, we're going to look at our latitude is equal to the northing of 103 minus the northing of 500. And our departure is going to be the easting of 103 minus the easting of 500. So we will then there's our latitude, the north-south line, the departure, the east-west line. Go through these two here again. Calculate that bearing and distance. And what do we have? What do we have? Anybody? Anybody? 10 degrees, 42 minutes. What quadrant are we in? Northwest? Could be. Confirm, deny? Okay. How about a distance?
50.96.
Okay, so I drew this a little incorrectly, but we still got the general premise of it, right? Exaggeration here a little bit. Actually, let's redraw it to make more sense. Get rid of this. So 500 is actually kind of over here. And we're saying that's a bearing of north 10 degrees, 42 minutes, and 38 seconds west. $500, 501. A little bit more north, and east is let's say 501 is actually like kind of maybe over here. Guessing. So we'll go through the same steps as far as calculating our latitude and departure. The northing of 103 minus the northing of 105 would give us our latitude. The departure, our easting of 103 minus the easting of 501. I'll write that down over here. Let's go. So again, the bearing is equal to the inverse tangent of your departure divided by your latitude. And your distance is equal to latitude squared plus departure squared. Take the square root of that. It's the old inverse routine. Nothing too terribly crazy complex. Kevin, you got a bearing and distance for me?
I don't have the bearing yet, but I got a distance of
38.04. 34.08. 34. I'm hearing all these numbers and they're just getting jumbled in my head. Okay, thank you. Well, that was difficult. Come on, coffee, kick in. How about bearing? Got a bearing? Got a bearing? From 103 to 105?
South 62 degrees, 49 minutes, 8 seconds west. East. Or no, never mind, that's southwest.
So
Northeast.
one more time on that angle.
62 degrees, 49 minutes, 18 seconds west or southwest.
Okay, so southwest, probably northeast, going the other way, right? Same difference. Let's move this over a little bit. Just to exaggerate some. So we're saying okay. I'm sitting on, I have my instrument set up at 103. I am back sighting 104. So that's going to be my baseline. This is now my 0-degree reference, okay, for where all my angles are going to be referenced from. If I want to turn an angle to the right from 104 to 105, we have those bearings. How do we calculate that angle? What is the angle between those bearings?
So you can just do 90 degrees. Well, you can add both of them and subtract 90 degrees, or you can do
No.
90 degrees plus.
If this bearing's going northwest, this bearing's going northeast. So a true north-south line is like somewhere in here, let's say. Our northwest bearing is the angle from the meridian to the line. Same thing over here. Our meridian to the line, that's our northeast. So we just add them up, right? So if you have your instrument set up here, we take a back sight, and that with that we set the 0 angle. We would then turn an angle 2 here from 103 to 501. Anybody confirm or deny those numbers?
So you're citing 104 and turning from 104 to 501?
Correct. That angle between those bearings. Now, still sighting here, and I want an angle that's going to be to the right. Correct. So we know this bearing angle is the angle from the line to the meridian or the meridian to the line. This right here, correct?
You can do your like northwest 0020 45 plus 10 42 38 and then minus 360 minus that, right?
You're close. So this line is the bearing of that angle from the line to the meridian. You're this much. Our backside is this angle. Subtract the 2 to get that interior piece. And then what I want, so it's an angle to the right. What's the actual like exterior, if you will? So yes, essentially you're going to subtract those bearings to get the difference between the two, and then take that from 360, so that would be all the way around. Don't time out on me. I come up with that as a number. So yeah, we're working with bearings. We want to find out the angle between these bearings. However, now we need to think, this is our baseline where 0 begins. What angle are we turning to get to those going around? Not too hateful? Pretty good? I have some instructions. When we're using the robotic total station, so here at school we have the Trimble S5 robotic total stations and TSC5 data collectors. When you are staking anything out, it is good practice. Once you get where you're going, you put your point in the ground. In Trimble, you have the option to store an as staked point. So that's where the location of where you put that point in the ground. That's a good hard record of what you have been doing, kept in the data collector. Always store an as staked point. Another thing, it's a good practice to do when we start staking out these offsets. For this example, we're going to stake 10-foot offsets of building corners. We know an offset is 10 foot this way, 10 foot this way at a 90-degree angle. We can calculate the hypotenuse between those two. Pull out steel tape, pull between your offsets, and make sure you get that hypotenuse that you calculated to verify those are square. It's just a good practice. You lay things out with one technology, change technologies, use something different to verify lengths, verify your distances. With this too here, I will provide a finished floor elevation for the building that we're going to lay out. And once we stake those offsets, we would put a grade on those offset stakes. So we'd tell the contractor either cut or fill some decimal feet to the proposed finished floor elevation. And as we hit all those with our rod, we will take an as stake point. Does anybody have any questions so far? Anybody out in the crowd have any questions? I also will need to specify here, when we are calculating our angles, calculating our bearings, I want to see what you write down in degrees, minutes, seconds. Remember, when you're doing these calculations in your calculator, punch in your degrees, minutes, seconds, convert it to decimal degrees, do your math, convert it back to degrees, minutes, seconds, and that's going to be the answer you're going to write down. So here's the plan of the house. Here I'm showing you, here's where point 501, 500 are. Those were the angles and distances we turned from our control points. Now we're going to do the calculations in kind of an older method. You would set two building corners, occupy one, backside the other. This is your new baseline. Set 0. This is your 0 angle reference. What we would calculate would be the angle and distance to set out each of these offsets that I have numbered 1 through 8. Another thing I want to point out, because of the way this house layout is here, it's not uncommon to kind of square the building up. So we project this line over, this line down, come up with what has been called a neat corner. Just kind of squaring it up, making it a nice simple square. We will put our offsets in to that neat corner, 10 foot off of that neat corner. Any questions so far? So we have dimensions to all the building lines. If you're occupying 0.500, 501, you're backsiting 500. What I want you to do is calculate the distance, and the angle. Now I wrote it this way, however, what I really want, because our instruments turn angles to the right, I want this from your baseline going clockwise. What I really want you to put down in the table below would be turning an angle to the right, coming around. We'll calculate this angle, subtract that from 360 degrees, we'll get our angle to the right. So in looking at this, how are we going to calculate that angle and distance? We know the length of our building. We know our offset. We have an opposite side. We have an adjacent side. So what we're going to calculate is the hypotenuse. Opposite over adjacent would be the tangent. Give you the tangent of that angle. So when I start doing all this stuff, I like writing my little abbreviations. In this case, tangent. I know the opposite side, which would be my offset. I know the adjacent side, which is my building line. Therefore, we can calculate this angle that way. So from there, then we'll move on to where's our next point. This is number one. We're going to go number two. We're going to stay on our zero line, but we're going to go our building length plus our 10-foot offset. Nothing too hard there. To calculate point number three, we know the length of our building plus 10 feet. We know the overall length of this building. So what would be the angle you would turn, and what would be the distance you would go from this point to get to that offset? That's the kind of math we're looking at here. Same thing over here. We know all of these are building height. Now we're going to come over our building width plus 10 feet. What's our new angle? What's our distance? So we're just doing some simple triangles, right? Triangles. Anybody got any questions yet? So I'm going to pan up here so we can see our table. Let me point this out here real quick too. I have point numbers 503, 502 on here as well. So we do want to stake out our building corner and our neat corner. What's your up, what's your over to get to that? What's your up, what's your over? This here would be a straight 90 degrees, the width of the building. Nothing too terribly complex, I hope. So in the table I provided for you here, we'll have to kind of lose the picture a little bit, but if we look at our lab, let's look at point 503, which is kind of catty corner to our building corner where we're occupying. I'm going to go up my line 52.67 feet. I'm going to go over my building width 46.67 feet. So there's the sides of my triangle. Okay, Just real quick, show you. I'm down here at 501, back sighting 500. I want to go over here to 503. What I want to find is this angle that I'm going to turn in the distance. My up also kind of being like a latitude departures, 52.67 and 46.67. That Pythagorean theorem to find a length, to find a hypotenuse of that triangle, right? A squared plus b squared equals c squared. Or we could say distance equals, call it my up squared plus my over squared and the square root of that. Not too bad, right? Just some simple right triangle calculations. So let me grab my calculator. We'll run through that one really quick. If you want to go through and fill out all your ups and overs first and then calculate your angles and distances, that's fine. So if I take my over 46.67, 52.67 divide, that's given me the tangent. So if I kind of said over divided by the up is going to be equal to the tangent of that angle. Or the angle is equal to the inverse tangent of your over divided by my up. So once I have that 4667 divided by 5267, I come up with that. I take the inverse tangent. I'm going to convert that to degrees, minutes, seconds. And I come up with an angle of 41 degrees, 32 minutes, 37 seconds. Can anybody confirm or deny that, or if we've gotten that far? I'm jumping kind of ahead a little bit here. Now if I take my 4667 squared, 52.67 squared, add that, take the square root, 70.37 feet. To get to building 502, the neat corner over here, what's my up going to be? Well, I'm going to be on that same line. So 0. My over is going to be the total width of the building, which you know is 4667. If I'm sighting this long line, what am I going to turn to get to that line? 90, correct. And I'm going to go a distance of 46.67 feet. Any questions on any of that? Okay, well, I worked through those two as an example for you real quickly. I'm going to turn you loose and let you go and start calculating. Do we need to go over the calculating bearings and angles between those? We can do that. So one other thing I do want to mention with this, when we stake this out, We're using our robotic total station. I would like to pull tape measure and pull some distances just to verify. Surveyors like to check, recheck, double check. Redundancy builds confidence. Some of the distances we can pull, we have 100-foot tape, preferably anything under 100 feet. We know this is a 10-foot offset. We know this is a 10-foot offset. Right triangle. We can calculate that hypotenuse and pull our distance between our offsets to verify the distance. So maybe on your sheet, you might want to write down what that turns out to be. Likewise, you can pull across to make sure your building's square. Check your diagonals. Anytime you're setting a box, depending on the size of it, if you can, pull a tape measure diagonals to verify that it's square and everything's good. Likewise, it would also be good to pull distances, just check, make sure that that is correct. That should be the length. These two offsets should be the same as the length of the building. Checking your offsets this way should be the same as the width of your building. So these are some of the ways. Take it after we get this laid out, take a tape measure, pull around, check some distances.